Okay, so we have what amounts to be our third problem in this sequence. I'll probably label this one as example 3 for finding a trig value, finding the outcome of a trigonometric function like so, given context clues like this. And we're going to take a totally different approach to this one. Okay, and let's see if the shoe fits here. So this one says if the sine of some angle is 1/3. Okay, and remember what we say, this is an angle, obviously. This is either a y coordinate, right? Or it's an opposite over hypotenuse ratio. That's what this 1/3 represents. And I know the unit circle pretty well, and I don't think I've ever seen 1/3 as a y coordinate for the angles that we're familiar with. So right now, I'm going to discount using the unit circle pretty much altogether. They're telling me that the angle terminates in quadrant 2, okay, which is helpful information, and then they want to know what the cosine is. Well, instead of putting this problem in the coordinate plane, I'm going to use a Pythagorean identity, okay? Because when you have an angle, this relationship will always be true for that angle, right? This value of sine theta squared plus the value of cosine theta squared will always equal 1. And I know what sine theta is. Okay, and just as a review, sine squared theta is sine of theta, quantity squared. So if I know sine theta is 1/3, I can replace it in this statement, square that. And then I have cosine squared theta equals 1. Now this just becomes an equation that it's going to help me solve for cosine theta, which is all they wanted to know in the first place. And I could have done this for all of these, okay? But it would have taken 2 or more Pythagorean identities to get there, right? Okay. This one, we do have a Pythagorean identity between cosecant and cotangent, so that one would have been 1. I guess I could have done it with 1 there. And then here, to get cosecant out of tangent, I only have the one tangent Pythagorean identity, which I could have found cosecant, or I could have found secant with, and then I would have had to keep going from there. So this one would have been a little bit more complicated to get to that point. I think I have another video actually on how to do that. Maybe I'll post that one too. Okay, but for this one, starting with sine, ending with cosine, makes perfect sense to use the Pythagorean identity to get there. So if I square this, I get 1/9 plus cosine squared theta equals 1. Okay, you know there's something coming up, right? So let's see. When we subtract the 1/9 to the other side, we've got cosine squared theta equals 8/9, because 1 minus 1/9 is 9/9 minus 1/9. We're not dealing with decimals here, folks. Okay, don't bother with that. So 9/9 minus 1/9 is 8/9. And then this is, again, this is cosine theta quantity squared. That's what this is. So how would I get cosine theta? I'd take the square root. So I'm just going to take the square root here and here. Now I've got cosine theta. Okay. So what's going to happen next, right? We take the square root of 8 and we take the square root of 9, the square root of 8 over the square root of 9. Now, something you always need to keep in mind, when you are the one that's writing the square root, right? When you have to take the square root of something in order to solve, right? You have to include both the positive and negative outputs from that. So here we end up with cosine theta is equal to positive and negative. The square root of 8 is the square root of 4 times the square root of 2. So I'm going to write that as 2 radical 2. And underneath, we get the square root of 9. The square root of 9 is 3. So here are my cosine values, but I don't accept all of those, right? Because this angle, as was given to me from the beginning, is in quadrant 2. And in quadrant 2, over here, we have negative x coordinates and positive y coordinates. Cosine values are associated, even though we're not using the unit circle, we can still use that as our basis for understanding signs in these quadrants. Cosine values are associated with x coordinates in quadrant 2. So even though I did get the positive and negative here, my final answer is negative 2 radical 2 over 3. Okay, so We can use these Pythagorean identities and scrap the unit circle and right triangle trigonometry altogether. Okay. In this case, made perfect sense because of the connection between sine and cosine. We just got to make sure we're keeping those sine clues, okay, in the back of our head when we're doing these problems.